Welcome to the Creating Instructional Materials, Building Successful Collaborations presentation. I'm R. Frederick Bergstrom, Lead Information Technologist, University of Rhode Island, Information Technology Services, Innovation Technology Services, and Supervisor of the Student Technology Assistance Program. The presentation will be on the University of Rhode Island's Information Technology Services Student Technology Assistance Program, STA. Student Technology Assistance, the big picture, emphasizes establishing and strengthening collaborations, team building, and creating meaningful educational content. It is committed to maintaining a high degree of professionalism and academic integrity. Employs traditional and innovative technologies to design and build educational materials. It also immerses undergraduate and graduate students in complex, real-world project management and development endeavors. Student Technology Assistants, who are they? All matriculating URI undergraduate students are eligible to apply for employment as Student Technology Assistants. ITS and the STA program judiciously adhere to all University of Rhode Island human resources and enrollment services hiring policies. The STA program has hired students from nearly every academic college, department, and major. Once hired, many STAs continue to work as STAs until they graduate. Let's take a moment and look briefly at 3 examples of STA projects. For now, we will only review portions of the videos and graphics. We will discuss each project in more detail later in the presentation. Example 1, Mechanism of Cisplatin video. Example 2, Static Friction Lesson video. And Example 3, Storm Surge Inundation graphic.
The tightly bound HMG protein causes destacking of the nucleotide bases, resulting in the DNA helix becoming kinked. In this way, cisplatin can be thought of as a monkey wrench in the DNA repair system. With the HMG protein bound to the DNA, the modified strand is not repaired properly, and so the cell dies. The success of cisplatin depends on its ratio of efficacy between cancerous and healthy cells. The tightly bound HMG protein.
The stopping distance is reduced when the speed of the car is reduced. We can use the equation we derived for stopping distance to see exactly how far the car went before it came to a stop. Say that the car was traveling at 15 meters per second, and we assume that the coefficient of friction between the road and the tires is 0.8. Plugging these values into the equation, we're able to find that the stopping distance is 14.3 meters.
Storm surge inundation. Note, darkest blue represents the original coastline. The varying shades of blue represent storm surge depth inundation from darker to lighter blue. What is the intrinsic value gained by participating in an STA project? You will need to make it more than just a job or yet another thing to have to do. Self-motivation is key for commitment and success. Start with a sincere and honest discussion with each stakeholder, team member, to identify what they would like to learn and gain from participation in the project. Check periodically with team members to verify that their goals are being met. Faculty time. Why should I invest my time on this project? I have too much to do already. Faculty incentives. This project may be a way to facilitate student learning and improve learning outcomes. Spending time on this project may mean spending less time to teach in a specific topic or material in the future. May provide extra time to teach the material in more detail and depth. May provide extra time to teach additional relevant material. Allows for new creative and innovative approaches to teaching. Task, add incentives you may think of to the list. Student time. Why should I invest my time on this job? I have too much to do already. I could get a less demanding job on campus for the same pay. Student-employee incentives, authentic professional development opportunities. Build a strong portfolio and resume, professional and social networking. Paycheck. It never hurts to earn extra money while gaining valuable work experience. Task, add incentives you may think of to the list. IT professional time. Why should I invest my time on this project? I have too much to do already. IT professional incentives, professional development, enjoyment of learning new technologies, professional networking, creates career advancement opportunities. I view this to be beneficial for how IT can support the university. Task, add incentives you may think of to the list. Every STA project requires its own production methodology. The best way to understand the types of instructional materials STAs produce is to see and talk about what they create. In the next several slides, we will look at more STA projects and highlight what they have in common and how they are unique.
Cisplatin is in a class of drugs known as platinum-containing compounds used to treat various types of cancers, including metastatic testicular and ovarian tumors. There are three key components involved in cisplatin's mechanism: cisplatin, DNA, and an HMG protein. It is this adduct-induced DNA bend that allows the binding of proteins which contain the high mobility group HMG domain. Once the protein is bound to the DNA, it inserts a wedge-like phenyl group of phenylalanine 37 into the widened minor groove created by the bend. The tightly bound HMG protein causes destacking of the nucleotide bases, resulting in the DNA helix becoming kinked. In this way, cisplatin can be thought of as a monkey wrench in the DNA repair system. With the HMG protein bound to the DNA, the modified strand is not repaired properly, and so the cell dies. The success of cisplatin depends on its ratio of efficacy between cancerous and healthy cells. The tightly bound HMG
Let's take a look at a free body diagram that shows all of the forces on a car's tire as it drives. The diagram shows a clockwise rotation, indicating that our car is moving forward. The frictional force is responsible for the forward movement of the car, so it points in the same direction as the car. There are also forces with Y components in the diagram, the force of gravity and the normal force. These two forces oppose each other and are equal in magnitude. We can use these forces to calculate the stopping distance of the car if the brakes are applied steadily so that no skidding occurs. Notice that as the brakes are applied, the direction of the static frictional force is reversed. Using energy and work equations, we can easily derive an equation for the stopping distance. we know that the static frictional work is equal to the static frictional force times the distance the car travels, and that the kinetic energy of the car is 1/2 mv squared. We can say that the kinetic energy of the car is equal to the static frictional work. This is because enough work must be done to reduce the car's kinetic energy to 0. Let's solve for the speed given values. The magnitude of gravity is 9.81 meters per second squared. The coefficient of static friction is 0.8. The angle of inclination is 45 degrees. And the radius of the turn is equal to 15 meters. Plug these values into the equation for v and solve. .4 meters per second is the fastest speed that the car can safely go. So we know that at speeds of less than 4 meters per second, the car falls into the center of the turn. At speeds greater than 36.4 meters per second, the car flies off the road. And at speeds in between these values, the car makes it safely around the turn without exploding. So we know that at speeds of
The nephron is a tubular structure similar to a porous pipe or hose. The glomerulus serves as the starting point for the flow through the nephron. First, the blood enters the glomerulus through the afferent arteriole. The blood exits the glomerulus through the efferent arteriole. The glomerulus is where the blood supply is filtered by osmosis and diffusion. As blood passes through the porous capillary loops, water and molecules smaller than about 50,000 molecular weight are filtered, passing into the Bowman space. This creates the luminal fluid flowing through the nephron tubule. About 1/5 of the total blood volume is continually filtered into the Bowman's capsule. About 99% of this volume is reabsorbed, leaving only a small volume to be excreted as urine. Each section of the nephron has a different morphology of cells making up the single cell wall, which causes differences in water permeability and ion transport. The first section of the nephron is called the proximal convoluted tubule. The proximal convoluted tubule is highly permeable, and about 65% of the filtered sodium and water leak out to be reabsorbed into the nearby capillaries. Old diuretics called carbonic anhydrase inhibitors mostly act on this portion of the nephron.
Cisplatin, nephron, and static friction videos. Things in common: teamed with URI professors to guide content and message, use 3D modeling, animation, and video editing software applications. What made them unique? Cisplatin video was created by a philosophy major, Nick O'Brien. Nephron video was created by a communication studies major, Steve Barbera. And the static friction video was created by a physics and film media major, Jeff Ferrucci. Student Technology Systems project structure and process. Teams, project management, product assessment, product distribution, user survey, more assessment, possible follow-up project. Some key features of successful STA teams. Trust. Members trust that everyone is dedicated to doing their part to the best of their ability. Equity and respect. The opinions, suggestions, and contributions of all team members are valued equally. Support. The team and its members must have the support of their organizations to ensure that required resources are available. Support. Team members support each other. Shared vision, working together for a common cause. Project management. Every team member is an ITS client. Identify every team member's needs. Understand and appreciate that everyone considers their needs to be important and valid. Align individual needs with team and project needs. Project management process. Perform a needs analysis. Identify short-term and long-term goals and how to achieve them. Establish effective communication and infrastructure. Design a working proof of concept model. Conduct formative evaluations as needed. Test final product. Evaluation of final product. Conduct a comprehensive summative evaluation. The next several slides will demonstrate how faculty, researchers, STAs, and IT collaborated to ensure that data and science are being accurately represented, proven pedagogic standards are being applied, and innovative technologies are employed to facilitate learning outcomes. Storm Surge Visualization Project. Things in common with all STA projects: employed standard project management protocols. What made this project unique? Required a larger team than most STA projects. Required working with multiple data sets, for example, GIS, LIDAR, emergency 911, storm surge models, bathymetric, elevation, and other data sets. Extensive computer programming by Dr. Stemple and STA computer science students. Required time for STA students to improve on and learn various programming languages and sophisticated data imaging and 3D modeling software. Data Visualization Project, Storm Surge Inundation, Narragansett Bay, Rhode Island. Faculty member, Dr. Austin Becker, URI Department of Marine Affairs, and Dr. Peter Stemple, Penn State University, whom, at the time of this project, Dr. Stemple was a URI Department of Marine Affairs PhD candidate. Data Visualization Project, Storm Surge Inundation, Narragansett Bay. Using varying shades of blue, darkest equals deepest water, this image depicts how sophisticated storm surge models project tidal flooding under several hurricane modeling conditions. The structures in red that would be most familiar to residents were hand-modeled. The smaller single and multifamily homes and generic structures were hand-modeled, and scripts referencing GIS and emergency 911 data were written to position them on the map. Virtual reality projects, challenges. Adequate time is needed to learn emerging technologies. Steep learning curve. How to represent and visualize complex, abstract concepts in a VR environment. For example, turn this MTX NADPH chemical reaction that students usually see as a 2D graphic into components they can interact with and manipulate as virtual objects. Virtual reality example MTX. Scene 2. In this scene, students are supposed to identify the methyl group on the MTX. This is meant to help differentiate between the MTX and the folate. Students can point and click on the methyl group to identify it. Once that is done, text appears that states that the MTX has a 1,000 times greater affinity than the folate. Virtual reality example MTX. Scene 3. In Scene 3, students can peer into the enzyme and compare the differences between the MTX and the folate. Virtual reality example, aspirin. Please take the time to review this Inbury poster. It describes the VR aspirin project very clearly. Virtual reality. Key takeaways: trust, respect, equity, support, shared vision, opportunity for professional development.